I am Bernard Lemarié from La Poste France, and I will now moderate the first session, Manage E-commerce Growth. And welcome everybody, and I would like to introduce Mr. Romaric Roussy from La Poste, who will present recent evolution of international packets processing. Romaric, it's up to you.
Hello everyone. I hope you find me well. A few words to introduce myself. I'm managing for La Poste all inbound and outbound operations. And to start my presentation, I just would like you to remind some element of context besides COVID. As you may know, in 10 years, inbound and out mail were divided by around 2 in volumes, where e-commerce growth by around 100 times. So we have to change profoundly the way we produce, and especially the way we produce inbound. Because as you may know it, France is a country which is an importer, and the volume coming from mainly from China within 10 years, we're growing from 10,000 objects a day to around a little bit less than 1 million. So it was a big challenge for us because for 10,000 objects a day, you produce it by hand, but for around a little bit less than 1 million, it's a different story. What we did, we completely redesigned the inbound site, which is in Roissy-Charles de Gaulle, Paris Airport, and okay, it's working. Just be a flag. And within this site, we decided we needed a facility to move bags arriving from planes around in order to control it, eventually push it to custom, and open it, basically. So we had two options. The first option was to use a classic sorter, a big sorter, a fix and stuff like that. But since we have a large number of uncertainty in volumes and stuff like that, we decided to move to a more agile solution using automated guided vehicles. Sorry. Basically, this AGV, these AGV, the objectives were to automatically sort all the inbound flow to the right facility according to production plan and to avoid errors, especially when we talked about customs. We wanted also to accelerate the flow to deliver a better quality. And very important, to reduce strenuousness for employees, because these bags coming from China, they're supposed to weigh around 20 kilos, which is already kind of heavy, but that can weigh up to 50 kilos. And one of the complexity of the project was that these AGVs had to move within an occupied site. We don't see it in the picture here, but you have employees walking around these AGVs, so it was a kind of a challenge to ensure the security of our employees. Up. Yes, working. I'm not sure. I was planning to use my mouse to show you the basic principle of the main principle of this AGV, but basically on the this is a plan of our site. On the right part of the slide. And basically, on the top of the slide, you have the how do you call that? Sorry for that. You have the planes unloading facility. So basically, you received, I don't know if everyone is familiar with it, but you receive big plane boxes, as you can saw it in any airport. These boxes are full with bags. And basically, what we're doing is that, well, you have to have someone to unload these plane boxes. You flash the bag, and then the facility is doing all the work by itself. So AGVs are taking in charge the bags automatically. System is orienting the AGV with the bag to the right facility. So the right facility are mainly control, as I said before, custom, and opening facility. And this operation are done fully automatically without any operator moving or unloading the AGV with the bag. And the system chooses automatically where the AGV with the bag is supposed to go according to production plan, and more specifically to the bag characteristic. Just to give you an example, French custom are very keen with some South American origins because of drugs previously. So they asked us to show to them all bags coming from certain destinations. So the system is fully automated so that all these destinations are sent to a custom facility. Right. Okay. So as I said before, this is done fully automatically, and the IT orientation system is how do you say that? Is calculating real time where the AGV with the bag has to go. The basic idea is for the bag to go straight to the right destination. But of course, real life is not that simple. So we had to introduce some kind of a backlog, which to make sure that the AGVs are still moving, where we need to unload the bag and then to reload it to the system once the queue or for some reason you have too many bags going to customs, for example. You have to make sure that AGVs are free to ensure the global production. So it's what you see on the right of the slide. It's the only operation when an operator has to move the bag is when you have to manage some kind of a backlog. The basic idea is to reduce that backlog to a strict minimum. In real life, it's the reality was that it was a how do you say that? We had a little bit more backlog than anticipated. Up. There we go. Is it moving? Yeah. The second difficulty we had was to make sure that this the AGVs were able to move safely in an occupied environment occupied by people. To make sure that so it's a double difficulty. You have to ensure the security of the people on one side, but you have to ensure also that the RGV is still moving. So what we have done was define some predefined routes, clearly identified on the floor, to make sure that on these routes nobody is putting some kind of a pallet or anything that can stop the RGV. And the RGV are equipped with a technology we call a LiDAR, which is a proximity radar. That detects if something is moving or standing close to the AGV to make sure that this the corresponding AGV will stop, and making sure that our employees were in a perfect security with robots moving around. And the routes, the predefined routes for RGV were defined on the floor with QR code, and this QR code is basically orienting the RGV and making sure that the RGV knows where he is, and corrected eventually his route. What we have done also was to automatically manage the replacement and recharging of the AGV battery. We built some kind of a robot. I didn't find any picture. I changed my phone and I didn't find any picture in my new phone. But it's kind of a robot that automatically is going to change the battery of the AGV to make sure that we have the right number of AGV at all time working along in the facility. One of the masterpieces of this solution is the supervision system. Because you're working with some kind of with robots, we had to define a person who is responsible to managing, to supervise all this activity of the 42 robots in the facility. Basically, the guy is using a supervision system which gives him the activity of each AGV. He also is able to see the buffer regulation for each bag opening installation, and eventually ordering the robot to go to the backlog I was talking previously. Is managing as well all the battery level for each, controlling as well all the battery level for each AGV, because the system is automatically ordering the AGV to go to the changing battery robot I was talking before. As well as the need for maintenance. If some kind of AGV is a problem on his route, the AGV is automatically sending a signal to the supervisor saying, I need help. Send me someone to unblock me or whatever the problem is. This supervision is on a fixed position, but we also are using a PDA to make sure the plant is 15,000 square meter. So we had to make sure that, especially when we have a problem with an AGV, we can go quickly to its position to make sure that there is no traffic jam behind him. So we equipped the manager with a PDA to make sure that they can quickly identify where the problem can be. Wrong button. Yeah. the supervisor is also connected with the management system of our bag opening lines, especially if he observed that a lot of AGVs are sent to the backlog. His mission is to make sure to open a new line to ensure that there is not too much bags put in the backlog, especially as you saw it before, the backlog is the only part of the facility that is not fully automated. So we don't want backlog. We don't want a big backlog. So basically, he make the interface, and that's probably something we can work on with AI or stuff like that in the future. But this guy is making the interface between the opening lines and the supervision system of AGVs. Next steps. At the beginning of the project, when we launched the 42 AGV in the facility, we had a lot of problems with the global efficiency of the system. Routes were not perfect, so we had to change them because some of the AGV were making 100 meters that were not necessary. So we had to optimize that. The problem with the QR code that were stick on the floor is that they were using how do you say that? Flute. Basically they were damaged and AGVs were lost, which is kind of a problem for an AGV. And as I said before, we had too much bags that were sent to the backlog. So we had to modify that position as well to make sure that not the position, but the orientation system reinforce the supervision system to make sure to reduce the level of the backlog. Got. But as a conclusion, and after it's a year and a half now since the system is working on an industrial level, the AGVs are really a great solution. First of all, to reduce costs, because with the fully automated solution that we implement loading and unloading the AGVs, we had an evaluation of around 20 positions of people that were used previously to move bags. And according to that, and I was talking about strenuousness, it's a great solution because we estimated that around 40 tons of bag were not lifted by operators with this solution. And the second benefit of the solution is that it's a scalable solution, and especially with e-commerce, you know that the volumes are increasing or not according to the season, according to COVID. So it's a great solution because we have today 42 AGVs. We can move up to, we estimated that around 65 AGVs, which is kind of a great solution to increase our capacity by a third. I strongly believe that the agility of the system is a great solution to adapt our inbound facility to e-commerce uncertainty. And especially in Europe, where you know that, where you might know that we will have to make some clearance declaration for customs for all objects starting 1st of July, and we don't know what kind of impact it's going to have on volume. So it's the agility of the solution is for us a great opportunity for the upcoming uncertainty in front of us. That's about it. I believe I'm right on timing, hopefully.
Thanks a lot, Romaric. Many thanks. Do you hear me?
Yes, very well.
Yeah. Thanks a lot. It was very interesting, and I share the argument about the scalable solution, which is effectively very useful in a changing world. So thanks again. We will have some questions. I precise that we will have some questions after the session, and we come back certainly on this subject. And now the next presentation will be will be from Royal Mail. Adam Collier and Stephen Jordan will present introducing scalable parcel automation into smaller plants. It's up to you.
Yeah, hi everybody. So to Royal Mail's presentation today is to give you an overview on the problems and issues we've had to consider introducing scalable parcels automation into smaller mail centres or smaller plants. My name's Adam Collier. I'm an engineering project manager for Royal Mail. I've been working there since 1988 and started as an automation engineer. I've held various roles prior to my current roles, all focusing on letters and parcels automation design and deployment. My role today is to lead the deployment of the second phase of large parcels automation that are currently being deployed into the 4 remaining large plants. I'm joined today on this presentation by my colleague Steve Jordan, and I'll just hand over to Steve to just briefly introduce himself. Steve will be picking up the second part of the presentation today.
Thank you, Adam. As Adam said, my name's Steve Jordan. Just to let you know, I've been working in the engineering division of Royal Mail since I started as an engineering apprentice back in 1989, so a few years now. I'm currently the engineering project manager for the next phase of the parcel automation into the smaller mail centres across the UK. So, Adam, back over to you.
Thanks, Steve. So, as a brief introduction, then the first phase of the parcels automation started in 2015, where we undertook delivery of the first SNS, Solution Net Systems large parcel sorter. Since then, we've sort of deployed 20 of those same systems, and they've been deployed strategically around the UK. The second phase, which is the phase that I'm currently overseeing as a technical project manager, is to deploy a further 4 large sorting systems into the remaining large sites. That should be completed by spring 2022, obviously next year. And what I'll do is I'll just sort of provide you with a brief overview shortly on the next couple of slides of the 2 largest systems that we've got, so that you get an idea of that. But having deployed that, the next sort of objective was to determine how we could then automate the smaller plants to release the benefits and reduce, as was previously explained, the manual handling activities on parcel sortation. So any solution that we were to sort of employ would need to sort the same parcel mail size ranges as the large PSMs and be reliable and provide world-class operational availability. So lots of considerations and lessons learned from the phase 1 and the earlier phases of projects needed to be taken into account. Again, they need to have a smaller footprint because obviously they're in a smaller site and space is constrained. And also having a smaller footprint was trying to reduce the operational workflow around that footprint also. And there's other constraints, low ceiling heights to reduce maintenance access, and of course be scalable. So the whole purpose is that we want a solution that is scalable for the output selections, for the inputs, the type of inputs, throughputs, and the number of tippers that we would employ on the front end to tip product into the induction area. Look at the next. So just to give you a sort of a really quick run through on phase 1, So the SNS system, as you can see, the image is probably not that great, unfortunately, but the SNS system employs a Bombay carousel sorter. As you can see on some of the bullet points there, it's 56 meters by 13 meters, and it's about 6 meters, 5.5 meters high. It's quite a large system. So we'd have difficulty deploying that into the smaller sites. It's got 2 induct lines with 3 semi-automatic inducts per line. We've got legal for trade, dimensioning, weighing on both induct lines. And this system can process parcels up to 450 by 350 by 200 millimeters. Yeah, it's the phase 1, and we've got 20 of these currently out there in operational use. If I just quickly run down to the next slide. So this is the phase 2A, we call it, so the second wave of large parcel automation. So we've got 4 of these systems currently in deployment. One, I'm sat here actually giving you this presentation from Newcastle, where our first system's being deployed and installed. Again, it's a large carousel-based system, but this the supplier for this is Bosystec, and it employs a push tray sorter, so a different type of technology. What that's enabled us to do is reduce the ceiling height for this specific design. It's slightly lower. Again, it has a similar capabilities as the previous system, does 10,000 items an hour. We have 6 semi-automatic inducts, but each induct themselves is probably not clear from the drawing, but you can see the six induct lines on the drawing there with 2 induct areas at either end. They each have their own independent induction and dimensioning for legal for trade. And then what this system is more capable of, this you can put 460 by 460 by 610 items onto this, and they can be inducted. We take the oversized off, and they're dealt with separately. But again, this is a large footprint machine. So the first 24 systems are large systems, and now the focus was on the scalability and getting a scalable solution for the following smaller sites. So the challenges and considerations we've got for automating the smaller sites, I mean, I think the 2 key points are the actual mail center constraints themselves and the functionality, the impact that the design of a small footprint system or a scalable system would have actually, on its physical functionality. So we've got limitations. We've got a lot of older buildings, and primarily they're the smaller sites. They have height restrictions, width. We've also got problems, as you can see on the images there, with tray work, cabling, lighting, and pillars. So there's obstacles in the way. So we need to be able to find a solution that was able to work around all those physical space limitations. At the same time, as I mentioned previously, reducing the operational workspace or keeping that as efficient, as effective as possible whilst providing that solution. And then the functionality aspect, because we use parcel address repair PARS, or parcel address repair system, for where we have operators that do manual keying for items that haven't got barcodes. There's a delay line and there's a response time for that, and that response time can add specific length to the sorter conveyors to get that return on the delay line. So it was necessary to employ a carousel sorter or some sort of function that employed a carousel sorter to limit that, to include that delay line within the physical rotation of the sorter. Again, the sorter output system, so the number of sort of selections, how these would fit in and how they'd be configured to suit each individual mail center requirement, and then the parcel pitch versus parcel throughput. So there's obviously a trade-off there. The bigger the pitch, potentially the lower the throughput. So all those things needed to be considered. What I'll do at this point is I'll hand you over to Steve Jordan, who will then take you through the scalable options of the program.
Thanks for that, Adam. So, need for scalability. So from the Adam, could you go on mute for me? Thank you. As Adam's gone through, absolutely the challenges and the considerations that we're seeing at the sites around some of the physical constraints we had and indeed some of the technical constraints we had from the smaller footprint. So this also underpinned the need for scalability that we were seeing with the smaller sites. So some of the sites, not just from the physical size and layout, but were forcing us to look for solutions where we might have different number of outputs, and indeed the volume of parcels through those sites would mean that we could have less or higher 4,000 to 8,000 parcels per hour. And also the in-feed configuration. What do we actually need at the in-feed? Did we need to have 2 tippers, for example, at every single site, or could we cope with 1? Would we need 4 induct stations, or could we do with less, or would we use more? And also how they would be positioned in those sites with, as Adam said, with the physical constraints of pillars, etc., that we might have. So all of those requirements added up, we looked to publish a request for information, and from that request for information, we received 7 responses from suppliers. And then initially they were shortlisted down to 4 based on their proposal, but the main criteria that helped us to do that in the initial shortlist was, what is the size of the machine, particularly not just the length and the height, but also the operational flow and the actual system itself, but also the height. We didn't have a lot of height in some of these buildings. Some, as Adam said, some of the older buildings that we were looking at, we were quite constrained. This then led us to understand that we needed a modular and a scalable solution. So to support the scalability and fitting those into the smaller sites, it needed to be a modular solution. And these would help us overcome those challenges that we've highlighted. With all that information, it supported us in our adjudication decision-making process and enabled us to select a preferred supplier that we could take into the design phase. So a modular solution, which is what I mentioned, was supporting that scalable solution. So what does it do for us? So it allows for different layouts to fit around the movable objects, pillars, walkways, and also some of the safety considerations we need to take in mind, from traffic of people, footfall of staff, etc., through the buildings. Also supports improved workflows for different operational layouts. Again, parcel containers, empty and full movement and storage from in-feed and tipping to the output. Options to vary the number of automated parcel container and tippers. So this supports scalability for future sites. Provides options for the configuration of the in-feed lines. Again, a modular approach supporting scalability, site variances and their requirements. And finally, for the modular solution, it can be configured for the number and type of outputs required. As previously said, some of our sites may only need 40, some may need 90. Looking into the future, that may vary also. So going back to looking at our preferred supplier and where we are at this point in time, we got a scalable solution. As you can see on the right-hand side of this slide, we've got the 3 images of different varying number of outputs, but also on the right-hand side there, you can see that we've currently got two tippers, and we're looking at 5 in-feed. So one of those in-feed would be able to accommodate parcels being tipped directly from bags as well. So it's not just the tipped parcels in our containers that we need to consider, it's also the bagged items that need to be input as well. As you can see, it's a horizontal loop carousel, providing the ability for recirculation and address keying delay line. So one of the most significant challenges that we found was implementing a delay line for the address keying. Other solutions at the adjudication often use long conveyor lines, introducing product tracking risks and additional maintenance challenges, often working at height. And that was another one of the main things that we were trying to reduce, was any working at height, making maintenance easier as we introduced these smaller footprint machines into our smaller sites. And then finally, for the scalable solution, outputs modular for mail center size, capacity, and selection requirements. So as you can see again on the figure on the right hand side, the sorter outputs are easily scalable to suit site requirements. Being compacted also means that the impact of the operational workspace is minimized, allowing for efficient movement of containers and realizing storage space not previously accessible. And then on to the conclusion. So the scalable loop sorter solution, what does that actually provide for us? So future flexibility and expansion. So it releases the hard to reach benefits, particularly within the smaller sites that we haven't been able to get to at this point. So not just with the sites we're moving towards automating, but now with the opportunity to automate even smaller sites. And of course, this drives down manual sortation and those costs down. The automation of smaller plants as well, including maximised address keying delay, being made possible without long conveyors taking over the valuable floor space. Options for the number of outputs whilst retaining footprint optimization, operational workflow and efficiency being key and made possible with the modular horizontal loop sort approach and the ability to recirculate the parcels. And finally, a tailored parcel sorting solution that provides a level of future-proofing. And this is for the smaller sites. This is in that changes can be made easily, having selected a simple and modular solution supporting future fluctuations, and these being mail center traffic requirements and the number of outputs and selections required. So thanks for listening. And Bernard, I'll hand back to you.
Thank you very much, Adam and Stefan, for this interesting presentation. We have a few time left, so I will go directly to the next presentation from Mark, from bpost, from Mark Sojolos, and the name is Automated Sorting of Ugly Parcel. So Mark, it's up to you.
Yes, hello everyone. I'm going to present to you a concept for the automated sorting of ugly parcels. So my name is Mark Sojolos. I'm Automation and New Equipment Manager at bpost. And I will take you through what we came up with as a concept for these ugly parcels. So first of all, I will explain to you what the ugly parcels actually are. So what are ugly parcels? So I took the liberty to have some pictures taken of actually these ugly items, and typically these are bulky, heavy, oversized items that are typically out of spec for your normal automation solutions. So usually about 5% of total volume is considered to be of a category that is processed manually and that we call the ugly parcels. So some examples there, you see on the upper left picture, you see some really big boxes. You also see some strapped together boxes, which is also particular to process. On the upper right picture with the two trolleys, the two roll cages, you can see some, on the left one, you see some really crappy packaging type items. In the right roll cage, you see a heat shrink polywrap item with all kinds of elements sticking out. And then below you see these deformed boxes, rolls and such on. So it's that type of product that we are talking about here. Okay. Because there's a delay on the actual feed, well, dear audience, so sorry for this little bit of technical hiccup. But so we are now on the ugly parcel handling slide, and I was explaining about our challenges that we face. So the most important one, of course, is that we face a lot of health, safety, and ergonomics issues when it comes to operators lifting these heavy parcels and having to move them around to do a sorting. So on top of that, we also see that we don't always get all the data that we would like to have of these parcels. So there's some inaccuracy and sometimes data is missing. What we also face is these items represent about 5% of total volume, but total volumes are increasing rapidly, as was explained earlier in some of the presentations. So meaning that as we do not process these all day long, 24/7, we have a time window, means that we have to buffer these items, and this buffering also takes up a lot of space. So those are challenges that we want to address. And how did we want to address it with this concept? Well, we wanted to find an innovative solution using the latest technologies that are being developed and being put on the market today. So innovative solutions for the handling of these items, but not so much looking towards traditional solutions with conveying and tilt tray or cross-belt sorting. We focused on solutions with robots, mobile robots, artificial intelligence, and such on. So we focused also on manual parcels that are quite heavy, between 20 kilograms, 32 kilograms, and that are quite large. So the design, the concept brief focused on these items. We, however, excluded what we call the 2XL type of parcels, the two-man handling that were like fridges or washing machines. Those we did not include in the scope. And as I just said, we wanted to maximize the use of artificial intelligence and machine learning and robotics, not only in the context of this concept, but as a learning for all future types of automation projects that we want to do in the future. So can you go to slide 29, please? Are we there? Okay. So concept overview and elements. When we draw up this concept, we had some operational objectives in mind. We did this exercise already at the end of 2019. It was already beginning of 2020, just before the whole Corona pandemic episode. So, and at that time, our prediction was that we would need this solution for like 14,500 parcels per day over a production time window of 10 hours. So I will take you through the concept on this slide. So we're going from left to right. So the items arrive, bulky items arrive in different packaging ways. We have some loose load, we have some on pallets in the roll cages. And at the unloading zone, there's already a split, and we kind of form trains with roll cages, as you could see in the pictures. So most of the items end up in a roll cage and then are being pushed over to the in-feed buffer station. So, and there they will be waiting until the production time window starts. And we then take out these roll cages and bring them to a number of pick and place robot in-feed stations. So we manage that with some vision technology and artificial intelligence to balance out the load on each of the in-feed stations. In such an in-feed station, there is this robot who will take the item, the big item, the ugly parcel, from receptacle and place it onto an AMR, an autonomous mobile robot. It will make sure that the label with the barcode is not on the bottom side of the item when it puts it on the AMR. Next, the AMR will drive away. You see this small blue line or box with an arrow. That is actually where we will do the data capturing. So we will have a tunnel with cameras to lift images, to read barcode and address, and also to dimension the item. And then we will also have a floor-based scale to take the weight. After that is done, we have a sorting sanction, and then the AMR will pre-sort these items into one of the 6 filling stations. So it's a pre-sort because the AMR will drop off the items at buffer lanes. So we use these buffer lanes. Why? Because we don't want traffic jam of AMR in front of a conveyor. No, so the AMR is able to evacuate the item onto this buffer lane, and then the robot is able to pick and choose the items, the sequence of the items that he wants to use to fill the receptacles. This allows you to have better fill rates when you fill up these receptacles. And all this is again supervised by vision technology, so that we know when receptacles are full and need to be evacuated, and new empty receptacles need to be brought to the filling station. So this is done again by AMR, and when full receptacles are finally processed, AMR will make sure that they arrive in front of the correct truck to be transported to the hub for distribution. So let's go to the next slide, please. Okay, so some details on this in-feed zone and operations over there. So we see a number of advantages. Obviously, when it's fully automated, it eliminates the manual handling of the parcels, so that's okay. As we don't have a lot of operators doing any lifting, so health and ergonomic conditions will be much better. And of course, we will probably get much better accuracy of data capturing. And we also think that there's a more stable throughput possible in such a concept, in such a system. Of course, there are still many challenges. So first of all, we are picking one item from a mass, a number of items inside a roll cage. That is not easy, especially finding the right robot and effector is very, very challenging, as I will come back to later in the presentation. Also, these are big items, our labels are standardized, so a small label on a big item, it's not always so easy to find the label, to avoid that the robot places the item with the label on the bottom. So these are really important challenges. Of course, you have to provide some safety fencing, but that's obvious when you have the use of robots. Some metrics here. So we compared the similar activities with industry setups. And this learned that an average cycle time of 12.2 seconds should be possible. So that means that 295 manual parcels per hour would be able to be processed by one robot, meaning that given the numbers that we used for the concept as a start, we would require 5 of these stations. Next slide, please. So looking more closely at filling station operation, well, we see some of the same advantages over there. Some additional advantages, like because of this automation solution, we would be able to have a dynamic allocation of receptacles. So for each of the filling stations. When a receptacle is full, there could be an empty position that takes over the destination of the full receptacle in order to not disrupt the good flow of the production. So we think that is an advantage that we can leverage here. With the buffer lane, we think that we can optimize fill rate because the robot can pick and choose an item of the correct size to be placed next to another item, which helps to make sure that you get a maximum of the out of the fill rate. Voilà. So some advantages there. Again, challenges. Those are very like the challenges in the earlier slide. What we again here see is the challenge of a robot end effector. We do have one advantage in this situation, that is that when the robot picks up an item, it is a single item, and because it is placed on the buffer lane and it is spaced from other items, meaning that the robot has better access to the items. Voilà. And so the metrics here, again, similar calculation. We chose an industrial version of a robot. We came to a cycle time of 13.3 seconds. Cycle time is longer because there's more travel time of the arm of the robot. So this gives us 270 parcels per hour, and this leads us to having a concept with 6 of these filling stations. Next slide, please. So, from concept to realization, it's very nice to have a nice concept, but what do you do next? So we decided to work on stage 1 and test the key enabling technologies that one would need to bring such a concept to realization. So in October 2019, actually already, we did some extensive testing on deep learning vision software. Normally you see the picture moving, it's a GIF. And so this worked very well. We were, however, limited to working with smaller items. So there's still some work to be done to confirm our results with the ugly parcels later on. But please click on the slide. So we give that a green smiley because this turned out to work better than we expected. Please click on the slide. So the next thing that we wanted to verify is the autonomous mobile robots for receptacle handling. So bpost has a fleet of legacy roll cages, and those date from a time where there was not such a thing as a mobile robot, and AGVs did exist, but never was the roll cage designed to be manipulated by anything like a robot or an AMR. So rather than exchanging all our roll cages, we decided to invest in finding a solution to pull our roll cages by means of a special gripping device. And you see 2 pictures there. So we had to custom design a specially adapted gripping system. But in the end, we were able to do that, and the gripping system is working with both our types of roll cages. So it will work for the roll cage you see on the picture, which is our parcel container, but also for our tray container, which is of a completely different design. So if you can click on the slide. We gave that also a green smiley, and we went on to do the next test of key enabling technologies. And if you can click on the slide. Now you should see 3 mobile robots in a picture. This is a test that we did recently. It was finished in March 2021. We tested an AMR sorting solution based on QR-based navigation. We saw some examples already earlier in the presentations. And also, we concluded that this technology is certainly able to do sorting. As you can see on the images, again, we did this initial test with smaller items, not with the big items, but the learnings apply equally for big items. It's just the scale that's different. So if you can click on the slide, please. Here again, we give this one a green smiley. Can you click on the slide, please? But we want to go a little bit further. So we think that QR-based solutions do have some limitations, and so we want to work on finding solutions to these limitations by using another type of navigation technology, which is called the SLAM navigation. And we are preparing to test that by end of year of this year. So click on the slide, please. And now we come to the much more difficult part of the concept, namely the robot end effector. We tested a number of solutions, and they had one thing in common. They were approaching the items from above. So what you see here in the picture on the right side is a vacuum lift solution, little Danish startup that combines a cobot with a traditional vacuum lift. And we see it works, but, and if you can click on the slide, please. Often it also doesn't work. So meaning that this technology is not really the end solution for our problem. If you can click on the slide, please. So we looked into, I call it a side gripper, meaning that it kind of squeezes an item from the side, whether or not it is assisted by some some carrying fingers that go underneath. We looked at a number of options. For sure, from the in-feed side of the solution, this didn't seem to be a good approach. It could, however, be a solution for the filling station. But if you can click on the slide, please. We actually gave it. Okay, I'm almost finished here. So, and this is I'm wrapping up. So, what do we think then is a next step to come to realization? We can click on the slide, please. So that's having a combined station. So having some human assistant actions to bring items towards a lifting device or robot carrier. The picture is a fully manual solution, but we are looking into a human-assisted robot solution. Well, this is not yet done, but we are looking into. And then I come to my last slide. Please click on the slide. So, what's the next step? Well, we want to build a pilot setup, and we are putting all elements in place to be able to work on that in the last quarter of this year and continue on into next year. So if we are able to do the next ICPA, be it online or live next year, I will probably be there with some more information on this and hopefully can tell you it was a success. But that is coming later. Thank you very much. I'm sorry again for the technical difficulties. Thank you.